Hello everyone, welcome to the another lecture of periodic classification of the element, class 11. Myself Suman Singh. So in the last class we have discussed about the ionization enthalpy, right? So now in today's class we will learn about electron affinity, or it is also called electron gain enthalpy, okay? And it is denoted by like this, delta Eg H star, right? It is also called electron gain enthalpy, okay? So So as we know that and we have already seen that the removal of electron from neutral atom involve what? Absorption of energy, right? We have seen that removal of electron from a neutral atom involve absorption of energy, okay? As a result, what will happen? There will be a formation of cation, right? Now the formation of anion also take place, okay, when electron is added to the valence shell of a neutral atom, right? If we are adding, suppose if we are adding an electron, okay, then it will form what? There will be a formation of anion, right? If you are adding an electron, so the formation of anion take place when an electron is added to the valence shell of a neutral atom, right? Now the addition of electron to the valence shell of a neutral atom usually involve what? Liberation of energy, okay? There will be a liberation of energy, right? Now this is because why this is happening. If you want to explain this, this is happening because the electron already present in the neutral atom repel the electron being added, okay? That is why there is a liberation of energy, okay? Now when we talk about the enthalpy change, okay, the enthalpy change involve the process, the enthalpy change involved in the process is called what? Electron gain enthalpy, okay, or electron affinity, okay, electron gain enthalpy of the atom. And if you want to define that electron gain enthalpy of the atom, we can define like this: the electron gain enthalpy of an atom may be defined as the enthalpy change involved when in the enthalpy change involved on addition of an electron to the atomic shell of an isolated gaseous atom, okay, of that element to form a gaseous ion. So I hope you have understood what is enthalpy, electron gain enthalpy, right? So it is generally represented by, when we talk about the representation, it is generally represented by delta Eg, okay, and delta Egh, okay. It is generally represented by this and is regarded as a measure of ease with which an atoms add an electron to form an anion, okay? So we can also represent like this. Suppose this is an X, which is a gas, and here what we are doing, we are adding an electron, okay? We are adding an electron. So when we add an electron, this X gas will change into anion, right? And there will be a this is a gas, and there will be a release in energy, okay? Release in energy, which is delta H, okay? And this delta H will be equal to, this delta H will be equal to delta, let me write here, and this delta H will be equal to delta Eg H, okay? So this is what, this is all about the electron gain enthalpy, okay? Now, the process of addition of an electron to the outermost shell of an isolated atom may be endothermic as well as exothermic. Okay, it will depend upon the nature of the element. Okay, suppose if you are using a large number of elements, then at that time the energy is released on addition of electron to the atom, okay? Now in such case, what we can do in such case, the electron gain enthalpy is negative, okay? When we are using a large number of electron, okay, the energy is released, okay, on addition of an electron to the atom. Now in all such cases, the electron gain enthalpy will be negative, okay? The electron gain enthalpy will be negative. Okay, now for example we can take halogen is what? Halogen belongs to group 17. Okay, we know that, right? And possess very high negative electron gain enthalpy. Okay, why this is happening? Because halogen um, atom are short. Okay, and this is happening because halogen atoms are short and sort of one electron only, as you know, right? Halogen, if you talk about the chlorine, we have taken the example of chlorine. It's in the outermost shell of chlorine, you will see there are 7 electron, right? So this is happening because the halogen atoms are sort of one electron to attain the nearest noble gas configuration. Okay, and have a strong tendency to add an electron in order to attain the nearest naval gas configuration. Okay, so in this case what will happen in case of some elements? Okay, the energy is absorbed during the addition of electron to the outermost shell of their element. Okay, and sorry, and such element possesses a positive value of electron gain enthalpy. Okay, so you can take the example of normal gas. Normal gas is what? It belongs to group 18, right? And have a large positive electron gain enthalpy. Okay, and this is because why it is happening? Because it has a its outermost shell are completely filled, right? This is because the atom possesses what? A closed shell configuration. Okay, and the addition of electron, or we can say and the added electron has to occupy the next higher principal quantum level, right, leading to a very unstable electronic configuration. Okay, that is why it become very difficult to add an electron to the noble gases, right? Now when we talk about the electron gain enthalpy, how it is expressed? So it is expressed in kilojoule per mole. It is expressed in kilojoule per mole. Okay, right? So this was all about the electron affinity or electron gain enthalpy, right? Now we will see the variations of electron affinity or electron gain enthalpy across the period or across the group. So when we talk about the variation of electron affinity or electron gain enthalpy across the period or across the group, we can say that in a general way, what we can say, in general the electron gain enthalpy value become less negative. Okay, on going down the group. Now on going down the group, what is happening at that time? On going down the group, the nuclear charges as well as the atomic size increases, right, regularly. We know that, right? On going down the group, the nuclear charge as well as the atomic size increases regularly. But we will see that but the effect of increase in atomic size dominate the increase of and dominate the increase in nuclear charge, right? So hence at that time what will happen? The added electron experience a less attraction by the nucleus. Okay, and consequently what will happen? The electron gain enthalpy value become less negative on as one move down the group, right? So I hope you have understood this, right? Next is variation of electron affinity in a period. So when we talk about the variation of electron affinity in period, in general what we can say, in general the electron gain enthalpy value become more and more negative on moving from left to right in the period. Why it is happening? This is because on when we move or when on moving from left to right in the period, the atomic size is what? The atomic size is decreases, right? Atomic size decreases while the nuclear charge increases. We know that, right? When on going from left to right across the period, on going from left to right across the period, what is happening? The um, the nuclear charge increases, right, and atomic size decreases. But both these factors result into a greater attraction for the addition of electron, or we can say that both this result, which is electron affinity, decrease in electron and decrease in atomic size and increase in nuclear charges, both these factors will result into a greater attraction for the added electron, right? Consequently what will happen? The electron gain enthalpy value become more and more negative in the period. Okay, so I hope you have understood this. Now after that, next one is electronegativity. Okay, so when we talk about the electronegativity, So we will see electronegativity in detail because it is a very important topic for your exam point of view, right? So now when we talk about the electronegativity, we know that the formation of a covalent bond involve what? Sharing of valence electron between the combining atom, right? Suppose I will give you one example. This is a carbon and this is the carbon, right? This is our form. This is what this, they are forming a covalent bond, right? So the formation of covalent bond involve what? The sharing of valence electron between the combining atom, right? These two are sharing a valence electron, right? Now, according to Jean Lewis, what he says that a single covalent bond is formed when the combining atoms share one electron each. Means if there is a single covalent bond, then means what? This electron is sharing one electron. This atom is sharing one electron. This element is sharing one electron. Okay. So formation of we know that, right? In a single bond there is an involvement of two electron, and in double bond 4, and triple bond 6, right? We know that. This one you have learned in class 10 also. So according to Jean Lewis, what he says that a single covalent bond is formed when the combining atom share one electron each. Okay. Okay. Now the shared pair is regarded with both the atom. Means what? The shared pair will be regarded for both the electrons, right? Both the atoms. But when a covalent bond is formed between two dissimilar, or we can say when now we can understand like this. When a covalent bond is formed between the two similar atoms, at that time what will happen? The shared electron pair lies just between the two atom, okay, and contribute equally to both the atom, right? If there is a, you see, if you are talking about this carbon and this carbon, so they are both same, right? They are same electron, same atom. So at that time whatever the sharing will be there between these two electron, it will lie in the middle, right? The sharing electron will lie in the middle, or we can say that the electron cloud will lie in the middle, or we can also say that the two atoms contribute equally to both the atoms, right? The electrons, the shared electrons contribute equally to both the atoms, right? At that time we can say like this. But the at that time what we can say, the covalent bond between the similar atoms does it 100% covalent, right? At that time what we can say, this covalent bond is 100% covalent, right? Because there no polarity is there, right? Polarity is not formed yet. Because there is no polarity is formed on the combining atom in the molecule, okay, we can say like this, that this following compound is a, or this following, yes, this following compound is a, or this following molecule, or this following atom, or following a compound is a what? 100% covalent, okay, or we can say that 100% covalent and no polarity is there, right? After this you have, I hope you have understood this, right? Now next is what? The situation. But when we, this is the simple, if there will be no problem, if there is a both the similar atoms is there, then there will be not, and there will no question will arise for the polarity, or when we talk about the bond which will be which will form between them will be 100% covalent, right? Now the situation become different when two dissimilar element, or when two dissimilar atoms shared electron, right? Suppose this is A and this is B. Now here this is different, this is different, right? So the situation become different when two dissimilar atoms, okay, shared electron and form a covalent bond, okay, form a covalent bond between them, okay. So in such a molecule, in this type of molecule, what is happening? It is sharing one electron, it is sharing one electron, and this one is sharing one electron, like this, right? These two are sharing one electron. So in such molecule what will happen, the covalent bond is formed to be partially ionic. At that time what will happen, if two dissimilar atom is there, so at that time the covalent bond will be partially ionic, okay, not fully ionic, it will be partially ionic, okay, because there is a polarity is generating, right? The covalent bond form will be partially ionic, okay, and the constituent atom appear to be partially positive and partially negative charge. We can say like this. At that time what will happen, the bond which will form between these two dissimilar atoms, what will at that time what will happen, there will be a partial negative and partial positive charge. Suppose it is, if it is carrying a partial positive charge, sorry, if it is carrying a partial positive charge, then it will carry a partial negative charge. Okay, in that case, if there is two dissimilar atom is there, at that time what will happen, the bond which will formed here, this between these two atom, the whatever the bond which has formed here, this bond will be what, this bond will be partially ionic, and the atoms will have a partial positive, as you can see here, and partial negative charge, right? Partial positive and partial negative charge, as shown here, as you can see right here, right? Now, in order to explain this phenomenon, okay, now one more scientist, this was all about the Jean Louis, but in order to explain this phenomena, Linus Pauling, okay, in 1932, he suggested that in a covalent molecule composed of dissimilar atoms, okay, if there is any covalent molecules, and if that is formed by a two dissimilar atoms, as it is, as in this case, as you can see, right? So in such case what will happen, and in such case the shared pair of electron is not exactly at the middle, but it shift to one side or the other side. Okay, at that time what will happen, the shared electron which is here, right, this shared electron will either shift to this side little bit, or it will shift to this side. I will draw it here so that you can understand easily. Let me draw here. Suppose this is A, and suppose this is B. So electron cloud will be, when we talk about the electron cloud, the, suppose there is a bond is formed between him, right? Between them there is a bond is there like this. Like this. So whatever the electron cloud will be there, it will be either to this side, okay, it will either be this side, in this side, okay, or it may be in this side. It means there will be a electron cloud will not be in the middle. If the electron cloud will not be here, it will either in this side or it may be in this side, right? So he introduced the term electronegativity. Okay, he introduced the term electronegativity, and what was according to him, he introduced the term, when he introduced the term electronegativity, to describe the shifting, okay, of the shared pair of electron from its equilibrium position. Okay, so he, at that time he introduced the concept of electronegativity to explain the uh, shifting of a shared pair of electron from its equilibrium position. Now, according to Pauling, what he says that the shared pair of electron, the shared electron pair shift towards that atom which exert a greater pull on it. Okay, what did he say? He said that the shared electron pair shift towards that atom which exert a greater pull on it. Okay, such an atom is said to be more electronegative. Okay, means what, if there is a bond which is formed between these two atoms A and B. Suppose A is sharing one electron and B is sharing one electron. So at that time what will happen, the electron cloud, if this one number B is more electronegative, then the electron cloud will shift toward here. The electron cloud will be, sorry, let me draw here. This is A and this is B. The electron cloud will be more towards the B, okay, than towards the A. The electron cloud will be more towards the AB, okay. The electron will shift more towards the B, right, if B is more electronegative. So the term electronegativity may be regarded as the property of an atom to pull the shared electron pair of the electron towards its own side in a covalent bond. Okay, I hope you have understood. Or we can say that the tendency of an atom to attract the bonded or shared pair of electron towards its own side in a covalent bond is called what? Electronegativity of that atom. Right, I hope you have understood. Means what we can say, if there is a bond between this, let me give you one example. Suppose there is an hydrogen and the bond is formed between hydrogen and chlorine. So whatever the bond electron which has been shared between them, the electron cloud, when we talk about the electron cloud will, suppose this is the electron cloud, the electron cloud will be more towards this, okay, more towards the chlorine as compared to the electron cloud, which is the two electron which is shared, right? It will be more towards the chlorine at that of hydrogen, because chlorine is more electronegative than hydrogen, right? So I hope you have understood this. What is the electronegativity? It is the tendency of an atom to attract a bonding or shared pair of electron towards its own side in a covalent bond is called what? Electronegativity of that atom. So there are so many process according to which we can find out the electronegativity. So according to the Pauling, this property is different from electrode potential. Okay, what he says that the electronegativity property is different from the electrode potential, ionization potential, or electron and an electron affinity, right? What he says that though it is related to this property in general way, it is different from different for the different atom. Okay, it is different from the it is different for different atom. Okay, now so many attempts were made, or various attempts were made to involve the quantitative scales of electronegativity, but among them two of them became more significant. One was Pauling scale and another one is Mulliken scale. Okay, so according to the Pauling, he has given one formula, and from that formula he told that we can find the electronegativity. So he, what was this formula? He has given this formula like this. He has given XA minus XB, XA minus XB, which is equal to 0.208. Okay, e a minus b, e a minus b, after that minus I am writing here under root e a minus a. Okay, a minus a into e b minus b. Okay, b minus b, bracket close, here half. So this was about the Pauling scale, or we can say that the Pauling which has given the formula. This is not so important, just I am telling you, just I am giving you an idea how he has calculated. Here XA, when we talk about this, XA is what? It is the electronegativity from A, of atom A. This is the electronegativity of atom B, and this one A minus A minus B is what? Bond energy of bond A B in a molecule AB. And when we talk about this one, it is what? Bond energy of bond A in a molecule A2, and this one is bond energy of the bond BB in a molecule B2, right? So this was all about how Pauling has calculated the electronegativity. I hope you have understood, right? And in the same way, Mulliken has also given one formula. This was X is equal to IE plus EA divided by 2. This was the formula given by Mulliken, right? I hope you have understood what is an electronegativity. Now we will see the variation. Okay, variation of electronegativity in the periodic table, which is across the period and across the period and across the group. Okay, so when we talk about the electronegativity in general, what we can say, in general the electronegativity increases on moving from left to right in the period, right? For the element 1, the element of group 1 possesses a less value of electronegativity. Okay, and the element partially have no tendency to pull the shared pair of electron and are said to be what? Electropositive element. Okay, whatever the element which is present in the group 1, this one, okay, this is what, this one is group 1, right? Not this one. Okay, yes, this one, yes, this one. When this group, so this group, the element of group 1, this group 1, right? So this the element of this group possess what? Least value of electronegativity. Okay, and this element partially have no tendency to pull a shared pair of electron and are said to be what? Electropositive element. Okay, now instead of affecting electron, they have a tendency to lose electron, as we know that, right? And prefer to form ionic bond. What most of the time it will prefer to form an ionic bond. Okay. Now next is on the other hand, the element of group 17, this one, the element of group 17, it will possess what? Higher value of electronegativity and in their respective period. Okay, so what we can say, the most electronegative element have a strong tendency to attract electron. As you can see, some of the electronegativities of some of the important element is given. You write this in your copy, right? Because it will help you in solving the questions. Okay, or it will help you in chemical bonding. Okay, so I hope you have understood variation across the period of electronegativity, right? Now next we will see the variation across the group. So when we talk about in general, what we can say, the electronegativity decreases on going down the group. Why it is happening. This is due to the decrease in effective nuclear charge with the increase in atomic number. Okay, in a group. So among all these elements, fluorine is the most electronegative element, as you can see it here, right? Fluorine is the most electronegative element, right? So I hope you have understood this. Now keep up to this. In the next class we will see this. So I hope you have understood this, right? So this was all about your about this chapter. Okay, this was all about this chapter. Yes, today you can, I don't think any, let me check. Yes, I hope this chapter is over today, right? So this was the last topic. So I hope you, all of you, have understood this, right? So try to solve this question. Okay, try to solve this question in the next class. From the next class we will start with the chemical bonding. Okay, till that, thank you, and I hope you have understood this chapter. Okay, till that, thank you.